In the last video, we talked about a measure of variability or a measure of spread called the mean absolute deviation. And what's cool about this is that it can be proved. It's a little beyond the scope of this class to show why this is the case, but it can be shown that roughly 95% of a data set is going to lie within 2.5 mean absolute deviations of the mean. So let me draw this on a little number line here. So if we have our number line, and let's say we take the mean of all the data points we have in some data set, and it is this guy. Well, this result says that if we add or subtract 2.5 mean absolute deviation, so let's say there's adding 1 mad, there's the second, but here's 2.5 mads. So this is the mean plus 2.5 mads. And on the other end, we have the mean minus 2.5 mads. Remember, mean absolute deviation is just the average distance of each data point to the mean. So let's say that we have this here. Actually, let me erase this. Let me make this a little more symmetric. So I'm going to just move this line a little bit closer so it looks the same distance away from the mean as the other one. So this is 2.5 mads here. And what this says is within these values, you'll find roughly 95% of our data. So let's do a little example to kind of see how this works. So suppose we have a fairly large data set. Let's say we have 1,000 data points. And we're told that the mean of this data set is 40, and the mean absolute deviation, the average distance from the mean, is 10. So we're asked, well, what are the bounds for the usual values in this data set? And up here, we called this area in here any data points that lie within 2.5 mads of the mean. We call them usual values. So we want to find these bounds here. So these guys we'll call bounds. So this is going to be our lower bound. And this is our upper bound. Okay, so let's work this out. Let me get a little more room here. I'm just going to scroll up. So for the first one, well, we know the mean is 40. So let's calculate the upper bound first. The mean is 40. And we want to be 2.5 mads above that. So 2.5 times the mean absolute deviation, which in this case is 10. So that is 40 plus 25 is 65. So that's the upper bound. And the lower bound is very similar. That's 40 minus 2.5 mads. So that's 40 minus 25, which is indeed 15. So we know roughly 95% of our data is going to lie between the values 15 and 65. And here's the mean of 40. I'll put that in there. So in this area, we'll have roughly 95% of our data. And outside of that, these areas here, these are our outlier regions or extreme regions. So extreme or outlier regions. They're values that are a lot bigger or a lot smaller than the other values that we have. And those together, they combine for 5% of our data. So we have 95% of our data in here. So here's 95% of our data. And then the remaining 5% is split up in these two areas. So we worked out part A. Here are bounds for our usual values. Anything between 65 and 15 we'll call usual values. And, well, if we expect 95% of our data to be usual points, well, 5% are going to be unusual points. So 5%, let me mark it in like this actually. So 5% of our 1,000 data points, so that's 0.05 times 1,000, which is 50. So out of our 1,000, we'd expect 50 data points. We would expect 50 data points. Give myself a little more room here. To be outside our usual region, and therefore outliers. And we'll talk a little bit more about these extreme or outlier points a little bit later in the course. But that's a nice result that we have with this mean absolute deviation. If we go 2.5 mads from the mean, around 95% of our data will be in that region. A quick note of a good way to use any sort of deviation, like the mean absolute deviation. You can use it as some sort of unit of measurement to compare 2 points in 2 data sets and determine which one is a more usual or more unusual value than another. So it's a really good tool for that. So let me give you an example of what I mean. Suppose that you're looking at a particular video game and a particular set of headphones, and you want to buy them off of some sort of internet site. And after keeping track of prices, you found that for the video game, the mean price is $80, and it has a mean absolute deviation of 7. And the headphone price is $220 with a mean absolute deviation of $30. So right now, you find that the price of your video game is $68, and the price of the headphones is $220. Now, you're willing to wait to buy either one of them, or you just want to kind of get the best deal on both. So you want the best deal on each one right now. Looking at this naively, you're thinking, well, if I buy the game at $68, I'm only saving $12. But if I buy the headphones at $200, I'm saving $20, so maybe I should get the headphones. But looking at the mean absolute deviations, let's see what one is actually farther away from the mean. So let's do that calculation. So we have this price. Let's do the video game first. So the video game is $68. It's $68. And that is going to be a mean of 80 minus some amount, let's call it X, MADs, X mean absolute deviations away from $80. So let's solve this for X. So we have subtract 80 from both sides. We get 68 minus 80 equals negative 7x. So negative 12 equals negative 7x. So 12 sevenths, dividing both sides by negative 7, 12 sevenths equals x. And 12 sevenths is roughly 1.71. That'll do for now. So that $68 is actually 1.71 mean absolute deviations below the mean of 80. So that's for the video games. Maybe I'll use a V for video game. And then for headphone, well, we have a price of $200. And that's going to be, it has a mean of 220, and that's going to be so many MADs away from the mean of 220. So let's figure that out. So again, we're going to solve for x, subtract 220 from both sides, so 200 minus 220 equals negative 30x. So that's negative 20, equals negative 30x. Dividing both sides by negative 30, we get 2/3 equals x, and that's roughly 0.67. So while you're saving more money by buying the headphones right now, that price is a lot closer to the mean. So it's only 2/3 or 0.67 of a mean absolute deviation away from the mean. So this is more usual compared to this guy. So if we were to graph these, just a little sketch, let's do the video game one in red. So here's a price of 80. And let's go 1 MAD below, which would be 73. And then 1 MAD below that would be 66. So this is x minus 1 MAD, and x bar minus 2 MADs. And I was saying x, but I meant x bar there. Sorry. And you could do it in the other direction, but I'm only interested in below the mean for right now, so that's fine. And then our point, $68, is going to be somewhere around here. So you can see it's quite far away in terms of mean absolute deviations from 80. With the headphones, here's a mean of 220. 1 MAD below, subtracting 30, would be 190. So this is my mean x bar. This is 1 MAD below the mean, 190. And this point here would be right around there. This is $200, and that is less than 1 MAD below the mean, so it's more usual. And if you want the best deal in some sense, you want the least usual value. You want the one that's farthest away from the usual mean price that you can get.